More than a century ago, backplanes stumbled off aircraft carriers like nervous toddlers on their first bike ride, wooden decks, canvas wings, and pilots clinging on for dear life. Supersonic stealth jets? That was pure science fiction, right next to flying cars and robot butlers. Fast forward to today, and the Navy is not just chasing dreams, it's building them with afterburners. Enter FAXX, the love child of a fighter jet and a Silicon Valley startup. It's not just here to fly, it's here to dominate the skies and make enemy radars cry. A fighter designed for tomorrow's threats. After decades of adapting nearly every American fighter jet to operate from aircraft carriers, the U.S. Navy is taking a new approach. It has opted to develop its own sixth-generation stealth fighter, engineered specifically for carrier operations, distinct from the U.S. Air Force's parallel projects. FAXX, short for Future Air Dominance X, is envisioned as the long-awaited successor to the F/A-18E Super Hornet, which, despite its proven capabilities, is nearing the end of its service life. The aircraft will also operate alongside the F-35C Lightning II, enhancing the Navy's carrier-based airpower. But unlike past generations, FAXX is not just about replacing an aging platform, it's about reshaping the entire doctrine of naval air combat. The spark of innovation. Hints of what FAXX could become began as early as 2009, when Boeing revealed a futuristic concept: a stealthy, twin-engine, tailless jet with a mixed-wing configuration. This early concept featured a cockpit for two pilots, but could operate autonomously when needed, a nod to the rising role of unmanned aviation. By 2013, Boeing updated its design, enhancing its radar-evading features by refining its shape and integrating supersonic intakes inspired by the F-35's design. This concept remained in the 40,000-pound weight class, emphasizing speed, range, and stealth. Simultaneously, the U.S. Navy began to signal its intentions. By 2012, an official request for information was issued for the FAXX program. The Navy announced its plan to develop a multi-role air superiority fighter capable of not only air-to-air combat, but also ground strikes, close air support, and electronic warfare. More than a fighter, FAXX isn't just another pretty face in the hangar. This jet is the Swiss Army knife of the skies, built not just to fly, but to think, adapt, and conquer. Imagine an aircraft so versatile, it can swap out its sensors and weapons like you are changing apps on a smartphone. One moment, it's striking enemy radar sites. The next, it's gathering intel or jamming signals, all without breaking a sweat. With open architecture avionics, the Navy can plug and play new tech as easily as swapping out a USB drive. It cruises at supersonic speeds without guzzling fuel through afterburners, because apparently it believes in efficiency and intimidation, wrapped in next-gen stealth that practically whispers to radar systems, "You didn't see me." It also comes with smart skin, yes, skin with built-in sensors that eliminate bulky pods and reduce drag like a fighter jet on an aerodynamic juice cleanse. Thanks to adaptive engines, it knows when to push and when to coast, giving it unmatched range and flexibility. But wait, there's more. FAXX is a social butterfly, seamlessly chatting in real time with satellites, drones, other jets, and even ground troops, forming a mega-brain network that shares data like it's posting selfies in a war zone. It's not just a jet, it's a flying command center, a stealth assassin, and a digital symphony all in one. The power behind the jet. Underpinning FAXX's performance will be the Adaptive Engine Transition Program and its successor, the Next Generation Adaptive Propulsion Project. General Electric and Pratt & Whitney are spearheading the development of two prototypes, the XA100 and XA100 and 102, designed to deliver 35,000 to 40,000 pounds of thrust, while maximizing fuel efficiency. These engines are part of a broader shift toward variable cycle propulsion, which can dynamically switch between modes for high speed or efficiency based on mission requirements. Smart design, smarter functionality. Incorporating smart skin technology, the aircraft's sensors will be embedded into the fuselage itself, allowing for seamless data capture without the drag penalties of traditional sensor pods. This contributes not only to improved aerodynamics and stealth, but also reduces maintenance complexity. By relying less on speed or stealth alone, FAXX will use intelligent design and sensor integration to outsmart adversaries. The platform will prioritize situational awareness, electronic warfare, and precision engagement, delivering a fighter that acts as both a sensor and shooter. Weapons of the future. The sixth-generation aircraft is being developed with future weapons in mind, including hypersonic missiles, directed energy weapons like combat lasers, and advanced electronic warfare systems. One key goal is to neutralize enemy air defenses through suppression and precision strikes, using a combination of kinetic and non-kinetic tools. Advanced radar systems with high-fidelity tracking will be capable of detecting even stealthy or low-profile threats. Sharing the burden of battle, FAXX will also fit within the Navy's Naval Integrated Fire Control Counter-Air System. This doctrine suggests that no single platform needs every sensor or weapon. It can instead rely on a shared intelligence ecosystem. One aircraft might detect a threat, another engage it, and a drone might guide a weapon to target, all seamlessly integrated. In this environment, FAXX acts more like a node in a larger system than a lone wolf fighter. This allows it to take on greater challenges while remaining cost-effective and mission-flexible. Range, reach, and relevance in the Pacific. A major focus of the FAXX design is extended combat range. This need is especially urgent in light of China's anti-access area denial strategies and the development of hypersonic anti-ship missiles like the DFZZF. Currently, Super Hornets and F-35Cs have a combat radius of around 650 miles, while China's threat envelope extends over 1,000 miles from its coast. This mismatch threatens the operational relevance of American carriers, as they must stay far from Chinese shores to avoid being targeted. FAXX aims to close this gap with larger internal fuel stores, more efficient engines, and in-flight refueling support from drones like the MQ-25 Stingray. The Navy wants to ensure that its carrier air wings can operate farther, longer, and with greater punch than ever before. The rise of collaborative combat aircraft drones. FAXX won't fly alone. It's part of a broader strategy that includes collaborative combat aircraft autonomous drones with AI-powered decision-making. These unmanned partners will work alongside manned jets to scout, jam, attack, or carry extra ordnance. The U.S. Air Force plans to spend over $8.9 billion on collaborative combat aircraft development between 2025 and 2029, indicating just how integral these robotic wingmen are to the future of air warfare. FAXX, alongside these drones, will form a hybrid strike force balancing human intuition with machine precision. If you enjoyed this deep dive into the future of fighter jets, give this video a supersonic thumbs up. Don't forget to subscribe and hit that notification bell, because you don't want to miss when we drop more high-flying military tech content. Until next time, stay sharp, stay stealthy, and stay tuned.